Hello everyone, Jack here. Thank you for watching. Today we're going to build a soft processor with the Commodore 64 SID chip using the Papilio Schematic library. So the hardware we're going to be using is the Papilio Pro. So this is Papilio Pro, and this is one of the new acrylic cases. And we have a audio wing connected to the CH wing slot, and it goes to a stereo receiver that you can't see here. So since there's been so much work and so many changes with the Papilio schematic library, I'm going to do a quick walkthrough of how to get everything set up. There is a quick start guide that has not been updated yet, but we will get that updated. In the meantime, let's go through it real quickly. If you go to downloads.gadgetfactory.net, you need to download two things. You need the Papilio schematic library, and you also need the Zap IDE. So we've already downloaded and installed the latest version of the Zap IDE, so let's just walk through getting the schematic library. So you want to click on it, you want to download. This is all pretty straightforward stuff. Shouldn't give anybody any problems. Okay, so when it's done downloading, you want to open it, and you want to bring up a new window, and you're going to want to put this on most likely the root of your C drive. I guess I haven't really tested it out in different places. This is where I've always put it. I do know that there might be problems with spaces, so I would avoid putting it in a path with any spaces. And then once you've copied it to the location you want it, get rid of the version number off of it. That will make it easier to update in the future. Okay, so we want to go into the directory, and it's broken down into two easier to understand directories. This is where all the source code, all the libraries live, and this is where the projects, this is where the template, if you want to make your own project, you'll find the template here, and you'll also find existing projects. So we're going with the audio SID simple example. However, we are going to start from scratch so that you can see how the whole process works. So if you want to save yourself some time, you can go ahead and just open up this audio SID simple and load the bit file to your Papilio Pro, and then run the sketch. But we're going to make a copy of the template, and we're going to rename it. So we'll call it the SID walkthrough. Okay, now this is only going to work for the Papilio Pro. Both of the Papilio ones, they don't have enough memory for the code. So the SID libraries require a lot of code space. Won't run on either one of them, so we're going to delete those projects. Okay, so let's open up the ISE Webpack. You also need to have the latest version of Xilinx ISE Webpack installed. Okay, so we got ISE to open. So we need to open the schematic, the top level schematic first of all. And we're going to get some complaints about the symbols missing, and that's because we haven't added the symbol library. We haven't added the library in yet, so we need to go to Tools, the Symbol Library Manager, and we need to browse to where we just So where we just unzipped this Papilio Schematic library, go to the Libraries folder, and then the Xilinx symbol library folder, and open the lib. Okay, so you should see it updates this and this, but we need to update this. Okay, so just hit next on this, keep hitting next, take all these defaults it's already set up. Now when you get to the device families, you need to check all, hit next, finish, and now we should have all those symbols available to us. So let's close the schematic and let's open it back up, and this time we should have everything in place. Okay, so that looks good. Let's try and give us as much space as possible. So what we have here is we have a default project with it's got empty wishbone slots, so empty wishbone slots and empty wing types. So the wing types are just set to the GPIO, the general purpose input output. Okay, so what we want to do is we want to add a Commodore 64 SID chip, and we want to connect it to wishbone slot CH. That'll be this one. I'm sorry, not wishbone slot, wing slot. Okay, so let's start out by removing this empty wishbone slot from wishbone slot 5. We're going to go to symbols. We're going to find the Papilio peripherals, the wishbone, and in there we'll see the Commodore 64 SID chip. We're going to drag it out here and we'll just click it on that empty wishbone slot that we made. Let's zoom out a little bit, and we're going to want to drag this new chip down roughly till it's by where the wing slot that we want is. Okay, so if we look at this audio chip, we can see that we need to connect two signals. We need a 1 megahertz clock, and then we're going to have to connect the audio data, the outputted audio data we need to connect to something, which will be a delta sigma DAC is what we need to connect it to. So let's start with the DAC. And if you go to peripherals standalone, we actually have a delta sigma or sigma delta. I see it referred to both ways all the time. We're going to drag this out, we're going to drop it and connect it to the output of the audio chip. So we have the data in for the DAC connected to the output of the audio chip, and then this is going to output to a single pin. So before we go any further, let's go ahead and free up the CH wing slot, and instead, if we go to Papilio hardware, you'll see the Papilio wing. Oh, that's not right, I'm sorry. We want the wing underscore audio. We can connect it here, and that's going to replace the GPIO with what we have available on our audio wing. So if we go and we look at our audio wing, you could see right here, hopefully you can see that good enough, but there are two pins available, left and right, or plus and minus. So that's all that's available on this audio wing, and when we dragged and dropped this this wing, it exposed those two pins, and we don't have to worry about how they're connected. We just know that if you connect the audio wing to CH, which this is row C, the top would be CL, the bottom is CH, you can actually see CH right there. Then we have those pins available to us, and they're connected to the right places. Okay, so since our DAC is only outputting one audio pin and we actually want two, let's go ahead and add, we have another standalone device here. We could add a splitter. So if we connect a splitter to the audio out, we'll actually get two outputs. And we can draw wires between. Oops, I didn't get it. Okay, so we're drawing wires between the two outputs and the audio wing input. Okay, so next we need to connect, or the final thing we need to do is we need to connect the clocks. And if you look here, you can see that we have the two clocks that we need exposed. So we have a 1 megahertz clock. So let's click on this, and it's the Commodore 64 SID audio chip that needs the 1 megahertz clock on its input. Okay, so that auto routed it for us. So we see that it routed this connection here, this wire for us. Okay, so the final thing we need is that the Delta Sigma DAC requires a 96 megahertz clock. And we see we have one of those available here on the soft processor. So let's go ahead and connect it. Should automatically route it for us. And yep, we see it connected. Alright, we can make it look a little nicer. Okay, so we should have everything we need here. This should be everything we need in the schematic editor for a Commodore 64 SID chip that's connected to the wing slot CH using an audio wing. So let's go ahead and let's synthesize this. We go to Design, we click on the top level entity, and double click on Generate Programming File. We should start seeing everything happen in the console window. And this is going to take a little while, so I'll go ahead and pause this, and when it completes, we'll come back. Okay, we're back, and we have a newly generated bit file that we can load. So great, let's go ahead and go to the directory that we created and find the bit file that we made, and make sure your Papilio is plugged in at this point, which we are not plugged in. Hold on a second. Okay, you can see I've got us plugged in now, and we should be ready to go with the hardware. So let's go ahead and right click on the bit file, and we're going to choose write permanently to Papilio board. Should bring up the Papilio loader, and it's important to make sure that we're writing to SPI flash. ZPUino soft processors will not work if you write it just to FPGA. It needs to be written to SPI flash, and you should see that it erases, verifies programs, and verifies. And so we should have a loaded bit file now. And the next step that we need to do is we need to open up the sketch, the example sketch in the latest version of the ZAP IDE. So we're going to cheat a little bit. We're going to grab the sketch from the example project that I showed you earlier, and we'll take it and put it in our directory. Okay, now I don't have this associated with the ZAP IDE. We can go ahead and do that now. Okay, so that opens it up in the Zap IDE, and actually I forgot one thing. Let's go back to the directory where the sketch is in. There's a folder called small.fs, and this is a small file system that will live in SPI flash. The Zap IDE will take care of it for you. Anything that you place in this directory will be copied into SPI flash and will be available to your sketch. So we're putting a SID file in there. If you want to put your own SID file, you would just copy and paste the SID file into here and rename it music.sid, or in the sketch you would change the name of the file. So right here we load out of small.fs music.sid. So you could change that to whatever file you wanted, but we'll leave it as is for now. Okay, so now the important thing to know is in this sketch, the SIDPlayer.setup, this is where we specify which wishbone slot we're connected to. So if we go back to our schematic, we can see that we connected to the audio chip to wishbone slot 5. So back in our sketch, we need to make sure that this matches up to the wishbone slot we're using. Okay, so next up we need to go to board and we need to choose the correct board type. So we're using ZPUino 1.0. This is a ZPUino on Papilio Pro. We want to go with the vanilla variant. The next thing we need to do is make sure the serial port is the correct serial port is selected. It's always the second serial port for the Papilio. And finally, while we're here, let's just make sure that the programmer is set to Papilio programmer. That doesn't have any bearing for what we're doing here, but it's good to check. Okay, so we should be ready now, and we should be able to do an upload to the board. Now it detected one file for small.fs, and we should see it's compiling everything right now. And right now it's actually appending that SID file. It's uploading it to SPI flash, and it's completed, and now you should be able to hear it start. Alright, so that's it. It's playing a SID file, and let me turn this down. Alright, so we just generated a custom system on chip design using the ZPUino soft processor and the Commodore 64 audio chip, using a Delta Sigma DAC to output it to an audio wing. So that concludes this tutorial. Thank you for watching, and I hope it was helpful.